right, sweet. Just picking on like what sort of aspect to kind of start from talking about Wavelet first. So, of course, in general, Wavelet in itself, it's a distributed ledger. It really was made for powering up all of our different sorts of enterprise solutions tackling commodity trade, especially with the platforms Clarify alongside HybridX as well. Um, the whole reason, like why new blockchain, though, which is kind of the very reason why we created Wavelet in the first place, was just solely because when we looked at the current market, so this was all the way back in sort of April 2018, when we finished developing up a couple of enterprise solutions, and we were really looking for figuring out how to get them into production. It was really sort of like looking at it, what sort of ledger is out there that is able to scale, handle a large amount of transactional load, alongside um, one that is able to handle custom functionality via the integrations of smart contracts. There was Ethereum, Hashgraph, there was Avalanche in the works back then, Nano, and a whole bunch of these other different sort of platforms out there. But least to say, of course, the ones which you could really build on top of, well, the only one which you could really build on top of that you in which you could build production smart contracts really was Ethereum. Thing was, of course, the Ethereum community is quite vast. It's been developed, hence why I developed toolings out, got domain and everything. But the pure problem then is how long exactly does it take to actually process transactions? How sort of reliable is Ethereum in a sense when it comes towards executing and getting transactions actually applied to the ledger? And how easy was it to sort of run your own infrastructure, run your own Ethereum node, not relying on the inferior infrastructure which powers products such as MetaMask, etc. And so the reality was like Ethereum wasn't necessarily a very good solution to look into back at the time. Who knows, with Ethereum version 2, things might change up. And that is definitely what I decided to look into, especially with the Casper, the whole new sorts of sharding protocols, etc. But basically, everything was somewhat vaporware during the time, and it was all highly academic research. And since the only real public ledger that people could really look up to was Ethereum, the natural solution is that we look into one of those vaporware projects and proceed to sort of get them into production, make them a reality. Especially because with the sort of core dev team we've worked on a huge number of open source projects alongside a large number of enterprise projects before. It was only natural that we would go on and assist with one of the ledger's ecosystems out. And that got us to start off with creating a new ledger, yes, being called Wavelet, being an initial Hashgraph implementation. So April 2018, Wavelet was basically a Hashgraph implementation. In all honesty, it wasn't 2 months later, it stopped becoming a Hashgraph implementation. But the whole goal was to kind of take Hashgraph, which back then was a completely permissioned blockchain, exhibited a very interesting sort of TPS rate, somewhere along the lines of 1,000 transactions ish per second, all the way up to 6,000 ish transactions per second on, it was 60 nodes, which we tested with beforehand. And it was sort of during the time, like I and the team were, we back then were much more acquainted with more generic software engineering backgrounds in distributed systems, in operating systems, in compilers and kernels, etc. That we were just getting into mixing our heads into the whole distributed systems, economic incentives, the crypto economics space, and everything by delving into Hashgraph headfirst. After those 2 months, developed a fully working implementation to realize there was nothing else we could really do on the fundamental consensus protocol side to really get Hashgraph to scale. So Hashgraph, by those 2 months, was sort of out of the question. We learned a lot about consensus protocols back then, like what are the sort of different attack vectors that you have to look out for? How exactly can you go from this number being the whole 36 TPS that Ethereum advertises with all the way up to 10,000 and so on. Like by reading, like it was, we passed through about 30 different sort of papers talking about all these kind of interesting new slew of consensus mechanisms back then. And then we're eventually kind of lost for a bit. 2 weeks after we sort of gave up on Wavelet being the sort of hashgraph implementation, all of a sudden it could scale up hashgraph. There was this sort of very interesting paper that got circulated around by Edmund Gunserer called Avalanche. Under this sort of pseudonymous team name, Team Rocket. And basically, it promised a lot of what hashgraph had to offer. It is what you would call a directed acyclic graph consensus protocol because, well, I guess we shouldn't go too much into the details with regards to that, but apparently because it was able to offer a huge scalability, talking about within the sort of 15,000 transactions per second range, while at the same time being fully permissionless. Permissionless in the sense that you could use Avalanche as a ledger that is run or hosted or powered by a whole network of entrusted nodes. So of course, that ability in itself is really, really promising and something that Ethereum, Bitcoin, and all the other public ledgers at the time really could not promise out in any way. We immediately went head on first to just about 5 days after that paper got released, working on implementing it, and we got initial implementation done in 3 days alone, since we just kind of got so used to building up ledger infrastructure back then. And then it kind of bit us again, the sort of same experience that we had over with Hashgraph, where we found out that Avalanche in itself was actually somewhat in its infancy regarding like how robust the protocol actually is in the presence of adversaries, attackers, or anyone else you could think of that could potentially disrupt a public ledger implementation. That did not necessarily go out so well. What then proceeded was about 5, 6. Well, it was really all the way up to the end of 2018, to which we were trying to wrangle around with Avalanche, just because it seemed like the most promising solution out in the market back then. Only to figure out that the way Avalanche was structured, it had a lot of great properties in terms of scalability, in terms of certain aspects of security, but Avalanche was missing a lot of the useful aspects that Ethereum and Bitcoin had, which prevented any sort of ledger using the Avalanche consensus protocol to support usable, practical functionality like supporting smart contracts. Hence, Avalanche was unable to guarantee some set of certain properties that allowed for a ledger to support smart contracts. And you can imagine as for us, in which we're working on quite a number of these different enterprise products that require scalability, true, but require all sorts of custom backend logic, all sorts of custom functionality. Avalanche just did not seem like a fit anymore at that point. But then we decided to take a very interesting route. We kind of got tired by then, sort of like looking at over hundreds of papers in the works regarding all of these kind of different decentralized consensus mechanisms, looking into how to support smart contracts in very unique ways and whatnot. I and one of the core devs, Hey-Yang Joe, we just sort of sat in the office one day. We were all of the team, we were having a sort of dev sprint over in Singapore, so kind of January 2019. We just sort of came to realize at that point that any sort of methodology to being able to support smart contracts really was just utterly useless. Like it was the only way you could really support smart contracts in Avalanche was to reintroduce something like proof of work or the sort of consensus protocols that you'd see in Bitcoin or Ethereum today back into Avalanche, which was just a really messy solution. We went out of our ways to make our own, which then constructed this whole unique kind of consensus protocol. Me and Hey-Yang were just consistently arguing. You could probably ask AJ or anyone else who was in the room when we were arguing about it. Like it was just kind of us staying in the office all the way up to 8 p.m. talking about, all right, how do we ditch Avalanche? Why can't we just build our own protocol? Of course, the hesitation in building your own protocol is all of a sudden now you're getting into the weeds of academics. getting into the weeds of like ensuring that your software works properly with respect to new problems that others have sort of faced when say, for example, Team Rocket developed Avalanche, and when Lehman Baird developed Hashgraph. And we finally got something out that very interestingly combines some of the former protocol bits that you would see in Avalanche, alongside some very interesting bits that we saw in Hashgraph to then create this sort of new wavelet consensus mechanism. So this is pretty much where Wavelet stands today. We've got our own unique consensus protocol. It exhibits a lot of very exciting new features that you would not see in any other sort of distributed ledger today. If you've heard of DPoS or basically delegated proof of stake, or if you've looked into Algorand, Dfinity, Cardano, they have their ledger, Werber's Praus, or Tendermint. They have very similar proof of stake mechanisms, like how exactly their consensus protocol works, and actually the way it works, it's actually very unintuitive, or because of hiding behind all of the mathematics that sort of power those ledgers, there's actually one cold hard truth that nobody really comes to realize, that actually come to show that, hey, how do any of these ledgers at all have any sort of security? These traditional or even the delegated proof of stake protocols or anything like that. It's very simple. In all of these sort of proof of stake ledgers, one of the biggest things they emphasize on is that every some amount of time, there is a random like subset, like just a couple of people picked out of the entire network. Think of the network of the ledger having 1 million nodes. We would randomly pick like 8 of the nodes, 100 of the nodes. In EOS's case, it was 21 of the nodes, and have those guys, for a brief moment of period in time, have full control over the entire network. Like for a brief period of time, they would be the ones that are delegated to then validate and finalize a whole bunch of everyone's transactions within the network. And if you think about that, like just thinking like very trivially, very straightforwardly, and a ledger where every 10 seconds or every 1 second or every half a second, who knows, only 8 or 100 people out of are processing the transactions of 1 million people. In no way, like if once you realize that all of these ledgers, your security relies on just a couple of people within the network, there's no way you could really be looking at them as public ledgers anymore. Hence, sort of fast forwarding there, Wavelet's advantage is that there's none of that sort of nonsense anymore. There's none of this sort of random sampling, or there's no reliance on third parties. We call Wavelet an LPOS solution, a leaderless proof of stake solution. It's the only one out in the market right now. And because of its sort of leaderlessness nature, its security properties easily rival that of Bitcoin, of Ethereum, of basically proof of work blockchains, though it's arguable that it could even be better than them. Solely for one primary reason being that we're using stake instead of computational work to facilitate the decentralization of nodes across the entire network. You can think of it, if computational power through the economies of scale can be controlled by these large sort of corporates, which we obviously don't want to control a whole public network of data, sort of governing cryptocurrencies and whatnot. If we used stake and had mechanisms to evenly distribute out validator rewards or whatever sort of economic means you could think of to get pearls or what basically our cryptocurrency into the hands of the people, then you can imagine that just a lot more sort of decentralization capabilities in decentralization and proof of stake versus proof of work in that case. But of course, like that whole thing in itself can be a very interesting sort of slew of debates, and happy to answer any questions on that end. But yeah, now that waveless consensus is done, safety, scalability, you can pretty much ask for whatever you want out of the ledger. You know,